Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on question number 11 in the Number Theory and Abstract Algebra chapter. So this question is testing your knowledge of groups and subgroups, a little bit of matrix math. We're told that GL of 2R is the group of all invertible 2x2 matrices with real entries under the operation of matrix multiplication. And then we're asked which of the following are subgroups of this group. So let's check. And the best way to check is to just see if they're closed under the matrix multiplication. So the set T is this set of all matrices that have determinant equal to 2. Well, let's suppose that we have two matrices, A and B, and that determinant of A is equal to the determinant of B, which is equal to 2. That's what they have to have in order to be members of T. Well, if you take the product A times B, and you take its determinant, well, we know from properties of determinants that this is equal to the determinant of A times the determinant of B, which will give us, in this case, 4. So this cannot be a subgroup because the product of these two elements of the group won't be in the set. It's not closed under matrix multiplication because the product doesn't satisfy the criterion that the determinant has to equal 2. Alright, so now let's think about U. U is the set of all the upper triangular matrices, and I'll just remind you that an upper triangular matrix is a matrix of the form A, B, there's a C down here, and this has to be a 0. Well, if we take two upper triangular matrices, let's do D, E, F, another 0. Well, what do we get? The question is the answer upper triangular? And the way to figure that out is to see what this element is down here. Well, let's see, that's going to have to be 0 times D plus C times 0. So yeah, it's just 0 plus 0, so that's always going to be 0. So yeah, that works. That's going to be closed under matrix multiplication. And then the last one, V, is all of the matrices that have trace equals 0. And trace is the sum of the entries on the main diagonal. Well, let's think of an example. For example, if we take the matrix 1, 0, 0, negative 1, that has trace 0. But if we multiply it by itself, that's just going to give us the identity matrix, which definitely does not have trace equals to 0. The trace here is equal to 2. So this is not closed under matrix multiplication. So our answer is B, 2 only.